Good morning, class. Today we are discussed the final application of dimensional analysis. This is most important application of dimensional analysis. Class 11th Physics Chapter 2 Units and Measurement. And the final application of dimensional analysis is to derive the relationship among physical quantities. So let's start with the third application of dimensional analysis. To derive the relationship among physical quantities by making the use of homogeneity of dimension. Homogeneity, that means what? When the dimensions of the physical quantities are same. Homogeneity means dimensions are same. We can derive an expression for a physical quantity of we know the various factors on which it depends. See, many physical quantities are depends on others. So you can say that one physical quantity, the dimension of one physical quantity is depends on the dimensions of other physical quantities. So we are taking the relationship among these physical quantities. Let us understand with one example. Example number 1. Let us derive an expression. Let us derive an expression for the centripetal force. Centripetal force is what we are discussed in the further chapter, upcoming chapters. I'll simply explain to you about centripetal force. When you are moving in a circular path, the force which is act towards center is said to be centripetal force. Now you are moving in what? A circular path. So the centripetal force depends on a particle of mass m, velocity v, and radius of the circular path is r. In this application, you often see the word depend. One physical quantity, which is force, depends on other physical quantities like mass, velocity, and radius. So we can derive the relationship between these physical quantities. Now, let's start with the solution. Let force F depends on mass, velocity, and radius. Let us assume the dimensions of these are: dimension of mass is A, dimension of velocity is B, and dimension of radius is C. When we move from proportional to equal, a constant is there. We have already discussed in previous classes. So force is equals to K, m raised to power A, v raised to power B, and r raised to power C. Where K is what? K is dimensionless constant. Dimensionless constant. And we are discussing in the previous dimensional analysis that those quantities which is dimensionless quantity, we are ignoring it. So writing the dimensions of the quantities of equation number 1. Now the first equation become K is dimensionless quantity, so F is equals to m raised to power A, v raised to power B, and r raised to power C. In this, we are calculating the value of A, B, and C. Now, putting the dimensions. The dimensions of force is M, L, T minus 2. The dimension of M is M raised to power A. The dimensional formula of velocity is lt minus 1 whole raised to power b, and the dimension of radius is calculated in length, so we can simply put the dimensions of radius is l raised to power c. Now when we are using the formula x raised to power a whole raised to power b, so we can say that x raised to power a into b. That means when a physical quantity having two powers, we can simply multiplying it. Okay, we are using the same thing over there. mlt minus 2 equals to c, here m raised to power 1 whole power a, so it becomes m raised to power a. In the same manner, l raised to power b, t raised to power minus b, and l raised to power c. Now another formula that we used over there, that x raised to power a into x raised to power b, so it becomes x raised to power a plus b. Yes, this formula is to be happen. Okay, now m is still single, so we are not changing the formula for l, m raised to power a, but see in this l is 2, l raised to power b and l raised to power c, so we are simply using this formula, so it becomes l raised to power b plus c, and t is again single, so it written in the same manner, t raised to power minus b. Compare the dimensions of the similar quantities on both sides. See, mlt minus 2, which is equals to m raised to power a, l raised to power b plus c, and t raised to power minus b. See, both the dimensions are equal. Comparison the dimensions. So a, the dimension of mass, here the dimension of mass is 1, so a is equals to 1. The dimension of length here b plus c, and here is 1, so b plus c is equals to 1. And the dimension of minus b here minus 2, so minus b is equals to minus 2. So we are simply given equation number 2, equation number 3, and equation number 4. Now after calculating, see, in the equation number 4, minus b is equals to minus 2, so minus minus cancel and b equal 2. Now put the value of b in equation number 3 at that place. So 2 plus c equal 1, or you can say that plus 2 goes in that side, so c is equals to 1 minus 2, and 1 minus 2, you know that it becomes minus 1. So the value of c is minus 1, the value of b is 2, and the value of a is 1. Now putting all these values in equation number first, put the values of a, b, and c in first, we get f is equals to k, m raised to power a means 1, v raised to power b means 2, and r raised to power c means minus 1. Put all these values over there. So f is equals to k m v square upon r. Let us understand with one more example. Assume that mass m of a largest stone that can be moved by a flowing river depends upon, see again the word depend, means mass of a stone depends on various physical quantities like velocity, density, and acceleration due to gravity. So we can derive the formula. And here one more additional question is there. After derive the formula, prove that, show that mass of this stone varies with the sixth power of the velocity of flow. Now again we are going to solve in the same manner. Mass depends, this is the symbol of depends, or you can say that proportional. Velocity, assume the power a, density, assume the power b, and acceleration due to gravity, assume the power c. Our work is what? To find out the value of a, b and c. Now when we move from proportional to equal, a constant is there. So m is equals to k v raised to power a rho raised to power b and g raised to power c. Give it equation number 1, where k is what? Dimensionless constant. Writing the dimensions of various quantities in equation number 1, we get m equal v raised to power a rho raised to power b g raised to power c. Now putting the dimensions of the various physical quantities. Mass m, so dimension is only m, L is 0 and T is again 0. So that is the dimension of m. Now velocity LT minus 1 whole power A, density ML minus 3 whole power B, and acceleration due to gravity LT minus 2 whole power C. Now put all the dimensions in the given equation here. Now we are again using the formula x raised to power a whole raised to power b, which is equals to x raised to power a into b. So m1 l0 t0, here l raised to l t minus 1 whole raised to power a, so l raised to power a t raised to power minus a, m l minus 3 whole raised to power b, so it becomes mb l raised to power minus 3b, and lt minus 2 whole raised to power c, so it becomes lc t raised to power minus 2c. Now we are again using the formula x raised to power a into x raised to power b is equals to x raised to power a plus b. Now see, first m. In that side only a single m is there, so no problem, we can simply write m raised to power b. Now see there, L are having 3 times, L raised to power a, L raised to power minus 3b and L raised to power c. So we are simply adding all these 3 powers. So it becomes a minus 3b plus c. And t, how many times t? 1 time and 2 time. So we are simply adding these 2 powers also, which is minus a minus 2c. Are you understand? Okay. Now equating the powers of mass, length and time we get. Now compare the powers. Here power of m is 1, here power of m is b. So you can simply say that b equal 1. Now here the power of a is a minus 3b plus c, and here is 0. So you can say that a minus 3b plus c equal 0. And there minus a minus 2c, and there 0. So you can say that minus a minus 2c equals 0. Now give the equations 1, 2 and 3. Sorry, 2, 3 and 4. Now put the value of b in equation number 3. How? See, a minus 3 into b is 1 plus c equal 0. So it becomes a minus 3 plus c equal 0. Minus 3 substitute in that side, it becomes a plus c equal 3. Give another equation, say 5. Are you understand? Okay. Now we are having equation number 4 and 5. 4 is what? A plus 5 is what? A plus C equal 3, and 4 is minus A minus 2C equal 0. So we are using simply addition. So A minus A is cancelled, minus 2C plus C is what? Minus C, which is what? 3. You can say that C is equals to minus 3. So that's the value of C, which is minus 3. Is it clear? Now, using the equation number 5, which is A plus C is equals to 3. Now put the value of C over there. A minus 3 is equals to 3. So A becomes 3 plus 3, which is 6. So the value of A is 6. So here we get the values on solving equation number 2, 3 and 4. A equals 6, B equal 1 and C equal 3. Now put all these values in equation number 1. So it becomes M equal K V raised to power 6 rho raised to power 1 and G raised to power minus 3. And you can write in that manner, M is equals to K V raised to power 6 rho raised to power 1 upon G raised to power 3. Is it clear? And see that mass is varies with the sixth power of velocity. So M proportional to V raised to power 6. Now, homework. These 3 questions is homework. So please, once you are able to solve these 3 questions, immediately you can send it to me on my WhatsApp group. Okay? So the homework is the velocity v of water waves depends on the wavelength lambda. See, velocity of water waves depends. Which physical quantities depends? Velocity. On what? Wavelength, density and acceleration due to gravity. So derive the dimensional relation among these physical quantities by the method of dimensions. The second question, escape velocity of a body depends, means velocity depends upon the acceleration due to gravity and the radius of the planet. So derive the relationship between these quantities. And the last question, the frequency of an oscillating drop may depend upon radius of the drop, density of the liquid and surface tension of the liquid. So establish the relationship for frequency dimensionally. Okay, thank you class.